Okay, we're moving on to lesson 8, which so far what we have covered has mostly been dealing with what? There's some things we've covered so far this year. So last thing we just did was feedback loops, right? And we have positive feedback loops and negative feedback loops. Okay, positive feedback loops are those that,
Don't change anything.
yeah, they're a feedback loop, so something is changing. That's why it's a feedback loop. There's always something changing, okay? So a positive feedback loop will enhance what is happening. So as we continue to add CO2 to the atmosphere, it causes it to continue to warm. And some of the solutions add more CO2, which causes more warming, right? That's a positive feedback loop. So something that would stop the rise of CO2 in the atmosphere and therefore stop the heating of the atmosphere and melting of the glaciers would be an example of a negative feedback loop in which it, what's the word we want to use for a negative feedback loop? What?
Decrease.
Less.
Stops.
Instead?
Decrease.
Well, it opposes that change that is happening. So it's kind of trying to negate it, right? Trying to go the opposite way of what is happening. So we're trying to slow the heating of the atmosphere, and one of those ways is to decrease the amount of CO2 in the atmosphere, right? Okay, so that's one way. What's another way other than decreasing the amount of CO2? What?
Sliding in microwaves.
The microbeads, right? So we learned about microbeads and how can microbeads help slow the warming of the atmosphere?
Flex it.
It reflects the heat and energy off back into space.
Okay. Rather than it hitting the surface of the earth, what happens when sunlight hits the surface of the earth?
Heat
It
What?
absorbs it.
Okay, so energy can be absorbed by the earth and the materials that are on the earth, and it can also be reflected. If it gets absorbed, it can be,
transmitted.
yes, to other things. So when that energy gets absorbed by the earth and the materials on earth, it can be re-radiated back into the atmosphere as what?
Infrared light.
So infrared radiation, right? Or heat. Okay? And that is what is happening with the energy from the sun. Do our greenhouse gases directly absorb that sunlight energy that's coming in? Maybe a little bit of it. Some of that heat that is coming in. It's going to absorb some of that. Okay? But most of it is light energy, right? Okay? And so when that light energy comes in, it's going to go through the atmosphere for the most part, right? Except for, maybe some clouds that reflect it off. Okay? So once it hits Earth's surface, then it can get reflected off, yes, but it also gets re-radiated back into the atmosphere as heat, and that is what is being absorbed then by the CO2. Okay, so it's not directly the sunlight coming in, it's after the sunlight hits things on Earth, gets re-radiated back into the atmosphere, that is causing the heating of the atmosphere. Right? Everybody following that? Okay, so the microbeads are sitting on the surface of the glaciers, and so rather than it being reflected back into the atmosphere as heat, that light is being reflected then, so it's not absorbing as much of that energy as what, say, a rock would absorb, right? Okay, it's reflecting that light, it goes back off into space, which cuts down on the amount of heat that's
Oh my god.
Yeah, we are 3 periods into the day. That should not be happening.
Why are you music?
Okay, so that's one of the solutions for helping to reduce the amount of ice that is melting, the land ice that's melting, right? Is everybody following this so far? Good. Okay, trying. Okay, so is this land ice just the only problem that we have? Okay, what did we learn with the permafrost?
It's melting.
Melting.
Okay, what is permafrost?
It's
It's frozen land.
Ice that's
Frozen
Ice
ground.
in the land.
Permanently frozen ground, right?
Yeah.
That is no longer frozen. Okay, so over time, as the atmosphere begins to heat up, it's causing a lot of different things to happen. One of those is causing the permafrost to melt, right? Okay, so how is that affecting other things? How is that affecting our sea level? The melting of the permafrost.
Permafrost is releasing more CO2.
It's what?
rising sea level.
How?
Because the land is going into the water.
Okay, so some of these places where permafrost is right next to
The water.
oceans, right? Okay, and so when it melts, it falls into the sea, which is causing. So it's helping with that sea level rise, right? It's adding to that problem. Let's see. Okay. What about sea ice?
Not-
Is that an issue?
No. It's melting, but it doesn't cause a sea level rise.
Right, because it's already displacing the volume of water, right? Because it's in the water. It's not displacing that volume of water. What about the glaciers, parts of the glacier that are underwater?
They're not doing anything because they're already underwater.
The
No.
volume are
Don't you think? Don't think it's affecting it at all?
Not the part that's underwater.
Not underwater.
It is causing it to rise.
How?
Because
Why?
it's sitting in the water and freezing.
It's like if you drop.
Okay.
Like you're sitting in the bathtub,
water,
part of your head is
Glaciers
above
in the
water.
are
you
receding and
know?
then it's like going into the ocean.
Okay.
And those glaciers are going away.
They put ice cubes in it.
I mean, that's what we're going to be learning about in this lesson. So we might have some ideas about how it can affect it, but we don't have a concrete idea about it. So I think in the next 2 lessons, I think that's what we're going to be talking about, really. Let me find. Maybe not. Maybe. I don't know. All right. So, things that we've been talking about, thinking about, developing ideas about are albedo and the melting that happens at the surface of a glacier due to the warm air and solar radiation. And we've been talking about how cutting the carbon emissions and using reflective beads can disrupt the feedback loop that is causing the melting to occur at a faster rate. Okay, so when we look at this picture here, not that picture. Well, maybe. Are there any potential locations of melt on a glacier that we should be paying attention to? So we can see the front edge of the glacier here, right? About when we look at it from this angle.
Underneath
So-
the ice.
So one of our solutions was to build this berm, right? Which was going to what?
Keep the cold
Keep
water.
the cold water.
Okay. So kind of keep the difference in temperature of the water separate from each other. Can they do that 100%?
No.
No. Okay. So there is going to be some flow there. Okay. So this water, keeping it colder by containing it in this area by building up this berm. So it's going to be colder here, warmer here. We're going to have the flow of water though, above that berm, right? Because what do we know about energy?
It moves.
Energy flows, right, from one area to another, one object to another, okay, or it gets transferred through a substance. In this case, we have this water that is going to flow here. This water is going to flow out as well. Okay, so we're going to see some flowing of the water there. So, are there any other areas that we should pay attention to when it comes to melting of a glacier?
Yes.
Are we just concerned about what's happening up above the water? Where should we also be concerned with? What's happening down here, right? No, that was backwards. Okay, so what questions do we have about what is going on here? Think to yourself for about 20 seconds. Okay, talk to your table. What questions you have?
Something that just was hot, warmer water is right there.
That's not a question.
That's like what's happening in my mind.
Yeah, but that's not a question.
Okay, why? There's deeper water in the deep, why is warm water in the deep?
Okay, well,
Well, that was my question.
what if it melts, then it'll make the ice, like, you know, what's that called, recede? Because, you know, like the bottom is there, so it's just gonna like fall out.
Okay, so what is a question that you guys have about what's going on? Let's start with table 2.
Why is it warm down there when it's supposed to, like, once you get farther down the water, it gets colder?
Okay, so why is it warm? Okay, deep warm. If you can't read that, it says deep warmer water and glacier ice interacting. So Liam's wondering about, like, why is it so warm down there?
Yeah.
Okay, table 4.
Why is it only melting in that one spot?
Why is it only melting in that one spot? 1.
Why is it the deepest part is the furthest back?
Is the deepest part the furthest back? Okay, 5.
Why is there a dent in the glacier?
Why is there a dent in the glacier?
Why isn't the top melting first?
Why is the top not melting first? Okay, so some things that we are going to explore as we go through this lesson. Okay? So, thinking about what we have talked about so far in this unit. I know, we've been on this unit forever. I know, we have covered a lot of stuff. I know, it is a lot of stuff for you to recall since August. I know all this. Trust me, I know. Okay? But think about things that could help you answer your questions that you have, which could include talking about particle motion, right? How particles move, what we know about that. Okay, how might you figure this out if you were there, and who might know about this already? So I'll give you about a minute and a half to discuss these at your table. I don't know if there's any place to jot these down. Not really. So just discuss them. You could put them on a Post-it. Would be fine.
Do we even have any questions here? I don't think we do. What information might help answer your question about what it explain, like, well, why, or what it might help? What information might help us answer the questions? Well, like the particle movement, the particles are probably moving faster than that one spot. And that's why it's like whenever particles move faster than something,
Like the information.
What a check, you like to.
Once we figure out,
I'd say scientist.
you should.
I might,
Or
You might know
just
about
water.
Someone who already knows.
I
Someone
would
who
make
already
donuts.
Um,
By diving down and looking.
on my phone, is that, I
If I was her, I would face it
feel like the water, oh, I feel the water.
water.
You were there. Exactly, and you were there. And then maybe like take the water and then go back to the surface and look at it under a microscope and see the particles.
Okay. So what are some things that what information might help us answer our questions? I know every table had probably some of the same questions, but you all told me different things, right? Okay. So what is some information that might help us answer the questions that we had about what was happening at the glacier? Table 5, give me something.
Teachers that know about it, scientists.
What information? You don't
Talk
need.
to them and they give us information.
Past research.
Okay. Table 4.
Oh, the water current.
Oh, that's a good one.
Yes. big brain.
3.
Okay, go for it, Junior. Okay, how the warm water got down to the bottom.
Okay. Okay. 2.
To like feel the water, how hot it is.
So the specific temperature of it. Okay. 1.
Dive down there and take the temperature of like the proper thermometer.
Okay, but what information is that?
The temperature.
Which table 2 just gave me. So I need something else. I'm hearing way too much whispering, guys. Table 1, I need an answer.
The volume of the amount of heat water.
The volume of what?
The amount of hot water.
Okay. In general, what information could help us to answer these questions? What do we call that stuff?
Research.
Okay? And ways that we can figure this out. Okay? Dive down there, get the information ourselves. What else can we do?
Check the direction of where the water currents are moving.
Okay, well, how are we going to do that? By gathering our own data. Are we gonna go there and gather our own data? Unfortunately not.
Field trip.
Unfortunately not.
Why can't we
Okay.
do the magic school?
How
Okay.
else? How else can we get this information?
Ask
Looking it
scientists.
up.
people who are already there.
So that's known as research, right? When we do research and we are telling this information to someone else, if we're reporting it in a document, we're writing down that information to share with somebody, what is something that's really important for us to do? Cite your sources. Okay, you didn't come up with that on your own, right? You got that information from somewhere. You need to make sure that you are citing that so that you don't get in trouble for copywriting or plagiarism. Plagiarism is a huge deal, right? When you get to college and you plagiarize, you can get kicked out for that. Just so you know. Okay? What else? How might we figure out this information? Is there anything else we can do?
Books.
Well, that's kind of research. Ask the experts. Which kind of, yes, that goes along with research. But if you're directly having a conversation with somebody. Okay. And who might know about this already? teachers. I know about as much about these glaciers as you guys do. This is the first time I've ever taught anything like this, so I know about as much as you guys do.
That guy in that video that was taking pictures of the glaciers.
The researchers.
So, researchers, scientists. Okay, so those would all be things that could help us find out more information about this, right? All right. So, one place that we can get information is
Google.
Our books. Antarctica.
NASA, OMG.
okay. So these different organizations that might have information, NASA being one of them. They have an OMG project. Okay, Oceans Melting Greenland is what it actually stands for. Okay, so let's see. International teams of researchers are studying what happens where the glacial ice meets the ocean waters in the Arctic. So we're going to watch a video from NASA in the United States who has a project called OMG, Ocean Melting Greenland. Sounds like sounds like it studies exactly what we want to investigate. Okay? Are we ready? You ready for this adventure?
No.
Let's go. We better hop in Magic School with us. I need to play the song while we're getting
You have to sing the song.
Oh, I don't know
The
about that.
Magic School.
Guess we can't watch Magic School Bus because Jake won't sing the song.
I didn't know the song.
Sing Mobamba.
16-year-old.
Jake even know how to
16.
sing.
Yeah, Jake's an expert. Every now and then.
You can see Barbie Girl.
Junior. Bro, you're gonna snap.
Dude, don't
No, you like this one, baby.
Okay, come on. Where's that?
Just a tiny little town in southeast Green. Kulisuk is just a tiny little town in southeast Greenland, and we've been launching probes out of here for the past 4 or 5 days. It's already been a fantastic year for OMG measuring the oceans. We launch them right out of this tube right over here. Open up the tube, you can look right down it and see the water passing by, or sometimes the icebergs or clouds or whatever it is we're flying over. We slow down a little bit and we just push these big gray cylinders out of the bottom of the plane, and they fall to the ocean and measure the temperature and salinity when they get there and radio it back to the plane. We're really trying to look at the ice and ocean all the way around Greenland. So we're dropping 250 profilers. We're going to cover the coastline all the way around. And in the spring, we map out the glaciers with a radar, also all the way around. So we're really looking at mapping all of the ocean ice interactions in Greenland as best we can with one mission. What we care about with OMG really is the breaking off at the edges. As the water eats away at the ice, then it can actually speed up that breaking off part. And when you dump more ice in the oceans, then it causes sea level rise. So OMG is really here to try and figure out how much are the oceans doing, how much is this kind of breaking off of the ice, it's called calving. How important is that relative to the melting at the surface? And more importantly, is the ocean causing some of this speed up of the calving? We think it is, but how widespread is it and how big an impact?
Open site. Open site.
Okay, so now you do have some reading in there. So we're gonna take some time, okay? Do some reading. We have, there is the different types of glaciers that they talk about there. And then they have some on page 58. There is a diagram there of what is happening. And on page 59 has a map of some data as well. So we are going to
Read.
annotate. Thank you. Which means, okay, you're marking up your reading. You might be underlining something or circling it or highlighting it. Okay? Please put your name at the top and the date on there as well.
19.
Yep. So make sure you're thinking about what we are actually talking about in this lesson, which is kind of like how the water is affecting the melting process. We've been focusing on the atmosphere. We're kind of shifting that to how the water is affecting the glaciers melting.
Oh my god.
Okay, if you're done reading, annotating, okay, you're gonna do some discussion about what you just read about. Okay, so you have some questions up here. There should be room for you on page 58 to jot down your guys' answers. So, how do NASA researchers build knowledge over time? How do they define system boundaries? How do they describe system inputs and outputs? What are the consequences of drawing the boundaries this way compared to how, well, don't answer that one because we're not gonna.
Bottom one?
This
Right.
one, because we didn't talk about that. I cut that out just due to lack of time. We need to get through stuff, so. 4 questions for you guys then to answer. Yeah, you can discuss. Everybody, I want everybody to jot this down on page 58.
You also write the questions and then answer.
No, you don't need to write the questions, just the answers.
Okay.
The more it happens, the more they know what's happening.
They select data.
Its goal is to find out where and how fast the seawater is melting, and they have to use plane and boat-based instruments, and then in recent years they use satellites.
The more it happens, the more they How do they define the system?
How they define
They use satellites and plane
their what?
and boat-based instruments. And boat-based like instruments in the past years.
How do they define system boundaries? Look at the coordinates of the code there. Is that what you mean by that? Like, how do they define the system boundaries? What are they talking about system boundaries? Like,
What system are we talking about?
like the whole data thing?
Melting
How far they can
system.
go to collect?
This is a system, right? This glacier is
There's kind of water in the sea.
include the ocean water in that. So, like, how do you define where the boundary of that system is?
The different ways that I
How do you determine that?
How do they describe
Is it talking about there's two different seasons?
where the ice?
Where
The ice, there's different seasons, there it is, that
yeah, so like
What?
wherever the ice starts melting. Stops melting.
Well, what are some inputs and outputs of your system? What did you, like, how would you define your system? What did you define as your system? What are the inputs for it? What are the outputs for it?
Inputs outputs are the ice.
For the system boundaries,
How do they describe system inputs and outputs? Because those are the two different.
would you say is the
The glacier.
the
The end of the
boundary
glacier.
of the system?
The outputs.
Because what are the components? What are the things that you're talking about for this system? What are the different components of it? Glacier, sure, right?
The water around the
The
glacier.
water around the glacier, those are two components.
The things that are like the channels.
Yeah.
We haven't really talked about those yet, though. Like, are they part of the system? Yes. So just based on the things that we've discussed, what are the components, so then what is the boundary of it? You know, what are the inputs and outputs of this?
What is the input and the output? It's like the glacier melting or the under. Yeah.
Oh, she probably fills up like the
You're talking about the components. The components.
no, right,
The gameplay is looking like everybody is. historic site.
Wherever
Wherever
the,
the-
no, wherever the warm water.
Yeah.
That's a lot better.
Wherever the warm water meets the ice.
Oh.
How do they describe? The things that get input are inputs and things are outputs.
Wow, Jake, that is so
Okay, so the input is something that we put into the equation, but we didn't put anything in. We just,
Well, you don't necessarily have to put it in there.
oh, so like,
putting
the
the
heat is like the input.
Yes. Sorry.
So the heat is the input and the glacier is melting is the output.
The things that go into the glacier.
obviously.
So things like the sunlight that goes in the glacier, yeah, melts it in the water. It's that one. Most of them.
Answer your questions wording.
Or even the glacier melting in the curve, all over the glacier, the front of the glacier. The bottom of the front.
Are we done with our questions?
Yeah.
Yeah.
Okay. If you're done, please sit quietly while your classmates finish up.
Sit quietly.
Educational system, professional setting.
Okay. As you're finishing writing your stuff down, if we look at this middle picture here, what are we seeing? What's in the middle picture that we've been talking about?
Ice melting.
That's in all of them. I'm talking about specifically what is in this middle picture
Calving.
here that has kind of been our focus.
The Jack
Nope.
Wolfsabane.
Which is also known as
It's literally.
Calving on the
Jump off.
Glacier, the
Nope.
glacier, the real.
Nope. Paige has it. You guys are thinking too hard about it. Okay. Paige, what'd you say?
The Illicit Glacier.
Illicit Glacier, right? On this picture, it's called Jacob Chauvin. I don't know how to pronounce that either. So, anyways, what kind of glacier then is Illicit?
An oceanic.
No, you're not. You're not even reading what it's saying. Sydney?
Floating extension.
Floating extension. So if we look at this page, okay, the floating extension is that bottom one, D, right? Okay. So, does it make sense that the Ilulissat Glacier experiences as much calving as it does?
Yeah. Yeah.
It should, because we have all of this under here that is ocean water, warm ocean water, right? Underneath of the glacier, it's floating out. It's an extension that has no ice underneath of it supporting it. There's no land underneath of it supporting it. It's floating on water, right? Warm water. Okay, what's the warm water doing to the glacier? Melting it. Okay? And because it's melting it and it has no support, then it starts breaking off there. That's why there's so much of the calving happening there. It would make sense if there's more calving happening to like a floating extension than, say, I forgot what that one was. Shallow cold glacier, which is what C is, right?
Yeah.
Because what temperature of water is up against the cold shallow glacier? Cold water, right? Okay, so it's up on, it's being supported by ground, and the water that's there is cold. It's coming directly from the glacier, right? Okay, it doesn't have any of that warm water in contact with it. So which of those two, of C and D, which of those two glaciers is going to melt faster? Should be D, right? Because it's in contact with the warm water, it's causing more melting to happen. Okay, so what are the similarities then between A, B, and D that we are seeing?
They're all getting
Took out from under.
Okay, so some of that undercutting that's happening, right? Because there's more warm water that's in contact with the glaciers. More in A and D than there is in B, but there's still some warm water contact in B as well. Okay? So why is that warm water down at the bottom?
Because it's cold up.
It's not circulating.
Ain't nobody know.
The Arctic ice melting up top is.
It's not moving like the.
It's way colder.
It's from the
Okay, the Arctic ice, listen, I know the bell's about to ring, but the Arctic ice is what?
It's like if there's fresh water.
Okay, so the Arctic ice that is melting from the glaciers is fresh water. That warm water is
salt water.
salt water. So why is the fresh water on top and the salt water on bottom? Not heavier.
Junior.
Nailed it. Hayden, you nailed it today. Good job.
I know. I can pay for the day.
You can have a high five.